Alright, today we have day 1 of chapter 1.4, evaluating trig functions exactly. So, first thing I want to get started with here, if you look down below, here is just a recap of our exact value triangles, our special case right triangles, our reciprocal identities, which I know that's kind of small and hard to see, and our cofunctions. So today we're going to find exact values for all trig functions at specific angle measures. Use the quotient and reciprocal identities to help us do that, and then lastly we'll use a calculator to approximate some trig functions. So what I'd like you guys to do to start off with is draw in this chart, and I want you to fill out all these values for sine, cosine, tangent, cosecant, secant, and cotangent. Reason for that, these are values you have to know. These need to be values that you haven't memorized and you can just come up with instantly, because if you can't, it takes way too long to do a lot of problems and you're going to run into some time. You're going to run into time constraints on things like tests. So what I'll be looking for here, sine of 0 degrees should be 0 degrees, or should be 0, so you write it as 0. Sine of 30, if you figure it out, that's 1/2. That should be root 2 over 2 for the sine of 45. The sine of 60, root 3 over 2, and the sine of 90 is 1. So this is how I'm looking for this table to be filled out. Alright, quotient identity. That's tangent equals sine over cosine. You could also use its reciprocal, cotangent. If I'm taking the reciprocal of the tangent to get cotangent, I take the reciprocal of that fraction to get cosine over sine. The way I remember what goes with what is this. The cotangent here has a c in front, c on top. Tangent goes with the sine. So let's look at a couple examples here. I know that's kind of like magic. It's pretty impressive, I know. So how could you use these identities to solve for tangent, cosecant, secant, cotangent if we're only given sine or cosine? So we talked about just a second ago how you can get cotangent from the quotient identity. And you can get these by taking reciprocals. And that's how you would do it. You can use all these this concept of reciprocals, the quotient identities, and everything is composed of sines and cosines. Tangent can be composed of sine and cosine like we saw up here. Composed of cosines. Cosecant composed of sines. So as long as you know sine and cosine, you can find anything else. So in this example I have, we're given sine and cosine and we want to find tangent. So using our quotient identity, tangent of theta equals sine, which is 3/5, over cosine, which is 4/5. Now, can't divide fractions. Instead, we want to multiply by the reciprocal of the denominator, which is the bottom one. So we flip the 4/5 to become 5/4. You can cross cancel in this instance, those go away, and leave you with 3/4. Alright, I want you guys to try this example on your own, which we're given sine of theta equals 6 over 11 and cosine of theta equals root 85 over 11. Find tangent. Then a challenge question. Once you, knowing what you know, try to figure out what quadrant theta should be in, based on what you're given. Alright, so use a calculator. The sine, this one's pretty straightforward. You're just literally typing in sine of 35 and hit enter. So when you do that, you should end up with 0.57336. Normally when you're finding approximate values, you round to 4 decimal places. Now to find the secant, we don't have a secant button on the calculator. So instead, we're going to use a reciprocal identity and convert it to a cosine. Now when you do this, one big mistake a lot of people make is they'll leave the 240 somewhere else, so it gets lost, and people do like 1 divided by 240 and then take the cosine of that. To do this in the calculator correctly, you have to find the cosine of 240 first and then do 1 divided by that value. Or you can do it using parentheses and then get the same thing. What you should come up with here is you should come up with -2 as a solution. So go ahead and try this third one on your own. Now, since that is a cotangent, there is no cotangent button. Keep in mind you're going to have to use a reciprocal identity to put it in terms of something that you have a button for. So that concludes the notes for today. Hope this makes sense. I'll see you guys tomorrow.